You want some pasta? You want some pasta? I'm about to. Well, I'm live on YouTube right now, but I'm about to be live on TikTok. 817-827.
Ready to go inside?
No.
Come on, Bubba. Say bye, Daddy. See you in a little bit. Bye.
I love you. Check the live. You guys come in during the breaks.
Bye.
Okay. Okay, let's go ahead and get started, guys. So today, we're talking about routing. So kind of to just recap what we went over last Friday. I know it's been a weekend. We were talking about inter-VLAN routing. So beginning of last session, we went over IP addressing. I went over longest prefix length. So hopefully you remember that like a /27 would be longer than like a /25 when I say the term longer prefix length. That's going to come into play here with routing. And then we went over inter-VLAN routing. So how do my different users and my different VLANs actually talk to each other? How do we make that happen? We needed a routing device, whether that be a multi-layer switch or a router, so that's sub-interfaces versus switch virtual interfaces. So now today, we're going to go over purely just routing. So I'm going to go over with you routing, the different routing protocols, IGP versus EGP. This language isn't really on the exam objectives anymore, but it's important in your day-to-day to understand some of the vernacular I'm going to use, even if it's not going to be like officially tested per se, right? So we'll do that. We'll go over static routing and OSPF as protocols. And if we have time, we'll go over first hop redundancy protocols as well. So the first hop redundancy protocols, as we know, that's like HSRP or VRRP. 1 second here. Okay. One sec. Gonna get something else on the screen here. Bring forward. Okay. Okay, so let's go ahead and get started, guys. And we're gonna start here with my course, my whiteboard. So we're gonna go over IP routing basics. We're going to go over the basics of IP routing. So essentially what I'm talking about there is what does an actual router do and how does it do it? And this really just relates to like a routing table period. And then I'm going to teach you how to actually read a routing table, because there's going to be lots of questions that pretty much ask something like this destination IP, which interface is it going out? It's going to give you an output of a routing table and you have to understand that. But before we understand how to read a routing table, the different routing protocols, we got to go over the routing basics. So I'm going to draw a little design here. Just a basic design. So we have two routers. We have R1, R2. They're connected, let's say, with fiber. So we'll say like 10 gig Ethernet ports. But just for brevity, you know, we're dealing with 10 gig, 25 gig ports now, even in the enterprise. It's not just purely data center with our like twin-ax or DAC. You know, that's like kind of almost common now. So we're just going to keep it simple with gig though. I don't want to complicate it too much. And then on this side, we have our users. We have our LAN, our campus. We can call that our downstream, our campus, our LAN network that hangs off of us. So this is gig 00. And we have our users. Let's say 10.1.0.0/24. Then we have our users over here. And that's going to be 10.2.0.0/24. And we'll say, right here is also a network. Key thing here, every Ethernet segment, every connection is its own network. So here at R1 and R2, this is a network as well. So we'll give this a /31, which is possible. /31 only gives you 2 usable IPs, and in a point-to-point environment like this, just point-to-point, we don't need a broadcast or a network ID. We just need 2 IP addresses to communicate in this kind of, segmented Ethernet segment. So there we go. Now the whole goal of routing, the whole goal is to let our neighbors know, and then you're putting yourself in the perspective of the router, is to let your neighbors know about the networks you know about. You need to advertise the networks you know about to your neighbor. Whether we have a point-to-point connection here or a router communicating with 40 other routers via a dynamic routing protocol like OSPF, the end goal of routing is the same. I need to tell my routing neighbors about the subnets, the networks I know about. So, R1 is going to be like, yo, I got this network attached to me, 10.2.0.0/24, and I need to send it to my neighbors. We're going to configure that capability. R2 does the same thing. It's going to be like, yo, I got this network attached to me. I need to tell it to my neighbors. Now, there is multiple different ways we do this. But at the end of the day, it's all with a routing protocol. We configure on the control plane, we configure that router with a routing protocol. Okay? So, routing protocols. That's a P. Protocols. We need to configure these routers with the routing protocol so that they can tell their neighbors about the networks they know about. So, what are the types of routing protocols? So, let's go over the types of routing protocols. So, there's going to be like a couple major categories here. There's going to be something called EGP, Exterior Gateway Protocols, and there's going to be something called IGP, Interior Gateway Protocols. I'm going to break down the EGP first because there's really only one technology that does Exterior Gateway Protocol now, that does what we call inter-domain or inter-autonomous system traffic, okay? So that is the Border Gateway Protocol. BGP is our only routing protocol that is under the category EGP, Exterior Gateway Protocol, that is going to send traffic between autonomous systems, between domains. So when we're talking BGP, which unfortunately we don't teach in the CCNA anymore, you're like at the ISP level. You're at the autonomous system level. You're at the transitive data center level. You may be in the cloud. You may be on a huge enterprise connecting off to an ISP that you're sharing routes via BGP. You're sharing your domain's entire networking information to another domain, okay? That's BGP, the Border Gateway Protocol. And it's under the category EGP, Exterior Gateway Protocol. And I guess I'll put that in there, right? You don't know these acronyms off the top of your head. Exterior Gateway Protocol. And then BGP is the Border Gateway Protocol. All right, not too much on that because, you know, it's not in the CCNA exam objectives, so we're not going to go over it. And then we got IGP. So there's going to be two major categories when it comes to IGP. That is dynamic and, of course, static. And then under the dynamic routing protocols that are IGP, we have more categories. We have what's called link state routing protocols, which guess what? We're going to spend a lot of time with that because that's what OSPF is. So OSPF, the open shortest path first protocol, is a link state routing protocol. We also have ISIS, which is huge in data center and in ISP networks. In an ISP network, when you're talking between all your Juniper routers, all your big routers or small routers, whatever, they like to use ISIS, okay? It's fast convergence, very similar to OSPF, but anyways. Okay, and then amongst dynamic, we also have something called a distance vector routing protocol, which is RIP. I mean, this was probably made in the 70s, guys. It was the first, routing protocol. It's distance vector, and it goes by a hop count, okay? So the further hops a remote network is away, the less we consider it a good metric, all right? That's RIP. And then we have, the Cisco proprietary one. We'll call it an advanced distance vector. Sometimes it's called a hybrid distance vector, right? DV is what I'll call it. And that is EIGRP, Enhanced Interior Gateway Protocol. Please don't call it eGRIP. I thought, when I first started, people kept calling it eGRIP. And from the GovTech sector, Tyler, you've probably heard it called that. It's not called that, okay? It's called EIGRP, right? So the Enhanced Interior Gateway Protocol. Now, on the CCNA exam objectives, guys, I really am only going to talk about OSPF and static routing. Now, why? Because that's the only thing on the exam objectives. So as much as I'd love to dive into EIGRP and the different K values and love to dive into ISIS, which is another link state routing protocol, I just can't because we don't have the time and it's not on the CCNA exam objectives. So, you know, we can't really do that. Static and OSPF is what we need to know and configure for the CCNA labs and for our exam, okay? Now, the whole goal of these routing protocols, and really the whole goal of a router, and I'm going to come back up here. The whole idea we got here, right? The whole point of it is to find the best path. We need to find the best path to a remote network. That's it. We need to find the best path to a remote network. And I'm going to go through with you how we accomplish that, okay? We need to find the best path to a remote network. At the end of the day, that's all our routers need to do. They need to build what's called a global routing table, build that global routing table based off their local connected information, based on the information that is advertised to it from its neighbors, and then when it gets requests from its users, destined to whatever, okay? Destined to Google, YouTube, enterprise shit. It needs to send you on the best path. And we're gonna go over the rules and how a router does that. And when we talk about routing protocols, I'm going to stick with static and I'm going to stick with OSPF. Now, some basic information that I want to just get out of the way so you can take your notes and we can get past it, okay? I'm going to go over the different metrics and administrative distances. So we're going to call this routing protocol administrative distance. Distances and metrics. We'll call it metrics, even though for OSPF it's called cost. So my typing is so fucked up today, guys. I'll keep it real. My wife took me to something called Burn Boot Camp, and like my arms are fried, dude. Like I've not worked out like that in a while. And then I got home and I was like, holy fuck, I need to teach. So that's totally my bad. I apologize. We'll probably have to do another makeup day tomorrow. But if you see me just lagging on the typing, it's because my arms are literally fried, okay? So, routing protocols, administrative distances, and metrics. Let's define administrative distance. So AD equals the trustworthiness of a routing protocol. So essentially all we're saying here is that these routing protocols, EIGRP, RIP, OSPF, BGP, they have an RFC standard, a request for common standard. They have an IEEE standard. They're mostly open source. EIGRP is the only Cisco proprietary one, which even now it has an RFC. But essentially tied to that routing protocol is an administrative distance value. And that value is how trustworthy it is to the router. So all we're really saying there is that from a value of 0 to 255, a routing protocol is going to have a number assigned to it called the administrative distance. And the lower the number, the more trustworthy that routing protocol is. So when we have the same thing being advertised to us, the same exact subnet, RIP versus OSPF, we trust OSPF better because it's going to have a lower administrative distance, okay? So let's just fucking knock them out, okay? So OSPF has an AD of 110, okay? We got to know that. It has an AD of 110. EIGRP, and I'm going to put internal here, it kind of matters, okay? Has an administrative distance of 90. EIGRP external has an administrative distance of 170. We got to know that, okay? We got to know that. RIP has an administrative distance of 120. BGP, just regular BGP, like eBGP is what we could call it, but has an administrative distance of 20, okay? iBGP, so there's something called internal BGP. I don't really know if it's going to be on the test, but administrative distance of 200. I have seen this. ISIS has an administrative distance of 115. And static, guys, by default, just the default administrative distance of when you put a static route is 1. So out of all these, I should have done them in like numerical order, right? But out of all these, static has the best administrative distance. So if I'm being advertised a route from OSPF, EIGRP, RIP, BGP, ISIS, a /24, the same prefix length, and I have a static route going to that same remote route, same prefix length, what's it going to choose? A static route, okay, over all the dynamic protocols. Did I miss any there? OSPF, EIGRP, RIP, BGP, IBGP, ISIS, and static. I think we're good there. Okay. Now the metrics, okay? So I'm just going to go over OSPF. We call that a cost, all right? That cost is based on bandwidth. Bandwidth of the link, okay? It's based on the bandwidth of the link. So what we're saying here is that if I have this router, okay, and it's got a connection over here, and it's got an old school dedicated like T1 circuit at 1.544 megabits per second, being very specific there because you might see that again, who knows. And then we have a gig over here with like single mode fiber. This is R2, this is R3, and this is advertising to us 1.1.1.0/24, and this is advertising 1.1.0/24, and we're in an OSPF routing neighborship adjacencies. Which way are we going to choose? Are we going to go over to the gig, or are we going to go over the T1? The gig, right? That's how OSPF works in its most basic way. It takes that link state, there we go, looks at that link and says, what's your bandwidth? That's the best path. And if I had another gig link here that was also a /24, like let's say this actually was a gig as well, then it has options. If ECMP is activated on your router, it'll just kind of load balance it across, just like even 50-50, right? Or you may have to configure some load balancing as well, depending like, anyways, but we'll get into that more and more. All right, now the metrics for like static, because that's the other routing protocol we have to know. So for static, it's hard set. Now what I mean by that is like it'll just be 0, right? Just by default it's 0, but you can change it as well, all right? So there really is no metric formula with static. With OSPF, there is a formula. It's called reference bandwidth. Reference bandwidth divided by actual bandwidth. And this is going to be in our OSPF section, so don't worry, okay? Those are the notes I need you guys to take down. Now, we're going to take a deep breath for about a minute, and I'm going to draw us a little bit bigger diagram over here, okay? I'm going to draw us a diagram, and we're going to go over how a router selects the best path right now, okay? So I'm going to draw this kind of environment. Let's see. Okay, R1, R2, R3. Actually, no. This will be R4. This will be R1. Okay. Now let me draw some, interfaces here and some networks, okay? So right here, this router is going to be advertising 10.0.0.0/27. This router is going to be advertising 10.0.0.0/28. And down here, we're going to be advertising 10.0.0.0/29. Okay? So check me out, all right? Let me adjust this real quick. Okay. This is going to be gig 0/0 shared between them. This is going to be fast Ethernet 0/1. And this will be serial interface 0/0. And those are T1 speeds. T1, 1.544 megabits per second. Now, I'm going to write these rules up. I kind of went over them Friday. What are the 3 rules for selecting best path. So what are the 3 things that a router looks at to determine the best path? Number 1, and I'll zoom this out a little bit, is longest prefix length inclusive of the destination IP address. Whoa. Sometimes I hate this zoom like GUI. Okay? Longest prefix length inclusive of the destination IP address. Okay? Number 2, lowest administrative distance. Okay? And number 3, lowest metric / cost. I say cost, like metrics are the overall umbrella term because EIGRP, RIP, BGP, whatever, they all have their own metrics. But CCNA is just OSPF, the routing protocol we learn, configure. So cost, okay? Alrighty. Now let's check it out. So right here, I'm going to be running OSPF. Here, I'm going to be running EIGRP. And here, I'm going to be running RIP. All right? So if you don't remember those ADs, I'll write them up here. OSPF equals 110. EIGRP equals 90. And RIP equals 120. All righty. Now, R1's going to have a user. I'm going to draw that user's layer 3 header over here. It's going to change a lot, okay? This is the source IP. Here's the destination IP header. That destination IP, or this IP address, this packet, right? It's going to get sent off to the router. We know that. It's going to get sent off to the router. So this is just PC1. PC1 needs to talk to wherever, okay? And we're going to set the destination IP right there. Alrighty. So this user wants to talk to 10.0.0.5. Now, let's build my routing table over here for R1. Let's build that routing table. So I'm learning about 3 networks, okay, guys? I'm learning about 3 networks. And I have my local. We don't need to put that for now, okay? I got 3 networks. I'm learning about, via OSPF, the 10.0.0.0/27 via gig 00. And my administrative distance, I might run out of room here. My administrative distance is 110. And let's say my metric is 1 right here, okay? I'm then, via EIGRP, the code in a routing table is D for EIGRP. Don't ask why. That's the code, the flag that it, anyways. I'm learning about 10.0.0.0/28 via fast Ethernet 00. The administrative distance is 90. We'll just say the metric is like 28. I'm just making that up, right? And then I'm learning about RIP. And I'm learning about the 10.0.0.0/29 via serial interface 00. My AD is 120. And let's just say my metric is 1 as well because it's hop count. Okay. So let's shake it off now. Let's shake it off. I'm going to make this like answer A, answer B, answer C. And there's going to be an answer D as well. This is our full routing table. Nothing else. There's nothing else on our routing table. There's no gateway of last resort. This is it. That's going to become very important because option D is going to be the discard option. Okay. Now guys, when my user needs to talk to 10.0.0.5, remember selecting the best path. Which way is it going to go? Is it going to choose A, B, or C? Which one do we think? If you don't know, that's okay. We're going to choose option C. Why? So 10.0.0.5. From R4, our network range is .0 to .31. Down here it's .0 to .15. And down here it's .0 to .7. .5 falls under all three of those. It falls under all three. Okay? So technically .5 can live here, it can live here, it can live here. All right? And if we go back to selecting the best path, what does the router look at first? The router is going to look at the longest prefix length inclusive of the destination IP address. So it is actually going to choose this path here. It's going to go out RIP. It's going out the serial interface because that has the longest prefix length inclusive of the destination IP address. Okay? Yep, the most defined network. So actually, this packet is going this way, out the slowest path, right? Now, obviously, we would never configure something this way. Like, we're network engineers configuring these networks. We never do it this way, right? But that's what it would choose. So it's actually going out the RIP path. Okay, we're going to do this one more time. I'm going to keep those network ranges up there. So now we have a destination to 129. So our router, and this is our routing table. There's nothing else in here. R1 receives this packet. It inspects it, and it looks at its routing table. What's it doing with that packet? Is it going to send it out to 3 networks it knows about? No. It's going to discard it. Okay, it's going to trip you up on the exam. Trust me. It's going to discard it. Okay? If the routing table does not have a route for the destination IP address, it just discards it. It gets dropped right there. Okay? That's what it's going to do. Now, this is where subnetting comes into play, right? Because I'm going to do something here. I'm going to switch it up a little bit. Okay? So let's say this is what we got going on here. Let's say this is 64. This is 64 slash 26. Okay? And let's say this destination IP is 23. So, it's the same problem, right? It's going to go ahead and get discarded because I still don't have a path for it. So, on my routing table, this is what I would have. Dot 64 slash 26. That range is dot 64 to 127. Okay? That's its range. So again, we don't have a solid path for it. This is why subnetting is so important when it comes to questions like these. Okay? Now let's switch it up again. I'm going to switch it up again, okay? All right, we'll make this a slash 25. All right? And we're going to say we're going to be destined for 120. Now where are we going? We're going to go out OSPF now. Yep, it's A. Because that falls within this range. Here, it also falls within that range as well. But what's the problem here? A slash 26 is longer. It's more inclusive. It's the most defined network. It has the longer prefix length inclusive of the destination IP address. Alrighty. Now, I'm going to give me a second. I'm going to redo this chart again, and then we're going to move on to static routing because it's going to be a good little lesson. Let's say we got something like this. I'm going to change my routing table up as well. Okay. Let's say we got 10.0.0 slash 24, 10.0.0 slash 24, and 10.0.0 slash 24. And we're all learning about it via OSPF. Okay? Let me clean up the routing table. Okay? Clean this up a little bit. Let me rewrite. 0/24, 0/24, 0/24, and we all have the same administrative distance. Okay. Alrighty. Now, let's talk about this now. I want to go to 120. All the prefix links are the same. Okay, they're all the same. So, I can't draw over my, okay, there we go. This is no longer applicable to us. No longer applicable. But now we look at our routing table. It's all OSPF. So is this applicable to us? No, it is not. And now it becomes an easy thing, right? Now it becomes easy. The prefix links are the same. The administrative distances are the same. So now what are we looking at? The lowest metric / cost. That's this number over here, guys. Okay? This is the metric, that's M. The first number over here is AD, okay? The first number in these brackets is administrative distance. The second number is the metric or the cost, all right? It's a gig port, so I just put the metric as 1 because it's directly connected. If you know this, if you know how to do what we just did, because the test may ask something, this is from practice exams I've created, I've done on other people's platforms. You get a destination IP address to whatever, right? 10.00.60. What interface is it going out of? It's going to output a routing table. You're going to have to look at that routing table, see the best path for that 10.10.60, whatever it is, right? It could be any IP. And then there's going to be 4 options you have to select. It'll be saying going out ETH0, ETH01, 2, 3. If you can do that, you're solid for the routing exam objectives, okay? You're going to be solid. For my Zoom chat, anything else? Is there any other questions on this? Okay, sweet. That's a down and dirty when it comes to IP routing. So I appreciate you guys. Some other vernacular I want to go over, guys. You may see this, okay? RIB. That stands for Routing Information Base. That is synonymous with Global Routing Table, okay? Global Routing Table. And this lives on the control plane. So what do we mean by that? Is like when I build a routing table and I use a dynamic routing protocol like OSPF, so I create OSPF in my entire environment, boom, we're doing happy OSPF neighbor adjacencies and full convergence on OSPF. Awesome. That's a control plane protocol. And that OSPF protocol that we configured, and the way we configured it, is going to build the global routing table. Now, when a packet gets sent on the wire to our router, it's going to reference the routing table the first time for that destination IP. And the routing table is going to be like, do I have a path to this? Yes. And then it's going to push that information down to the fib. That's the forwarding information base. That forwarding information base is at the data plane. That's how it switches the packets in and out, right? So that's like, hey, packet inbound, it's destined for 10.00.60, immediately switch it out gig 00. And for like a simple network, like a stub network, something like this, like router out to ISP, where essentially here's your out. Your fib is simple, right? It's just switch all packets out. Unless you have a VPN, then you can get into there. That's the data plane. Yeah, the rib is the brain, fib is the muscle. That's a good way to look at it, right? So that's like where the actual packets come in here on gig 00. Actual packet comes in. The routing table builds the fib table for us based on that information, and then quickly switches that out. The protocol that's like kind of standard with this that builds the fib for us is something called Ceph. Cisco Express Forwarding. I've been in environments where sometimes I look at the CEF table versus the routing table. It's beyond the CCNA. I just wanted to let you guys know. You can see the fib table. Oh, man. It's like show IPsec, something like that. It depends on the iOS XE version. But yeah, rib, routing table, fib, forwarding table, okay? Alrighty, we're gonna take a little break. Really, guys, that's all I need you to know about when it comes to basic IP routing. I have the slides that you wanna go over, just some more like factual information, like if you wanna look at the acronyms, things like that. Next, we're gonna do static routing. So let me share my screen now. So this is gonna be our static routing lab, okay? We're gonna do this. I'm gonna do that for you guys. And then, well, no. I'll do this and then you'll do it on your own, okay? Let's take an 8-minute break. I don't wanna be up till 10 teaching, no offense. We'll come back at 7 o'clock. We'll do our whiteboard session of static routing and then we'll jump right into it, okay? Okay. TikTok chat and my YouTube chat. Let's check it out. Yeah, you don't touch fib. Sometimes I've had to look at it, but yeah, you don't touch it. It's all about the rib, right? The routing table builds like it's the brain for that information. So very true, very true. I liked your K dot. I liked your analogy. Rib is the brain, fib is the muscle. So if you see that on my next slides, bro, I got you. You know, I'll send you some. I'll send you some money for that for that quote. Yeah, you don't. It's just like what I tell. And I got your email, bro. SD card. I got your email. I meant to email you back this weekend. It was just Father's Day. It was a crazy weekend. I just like to teach it because I like to give engineers the deep understanding that you don't get with CCNA sometimes. You know, because eventually, if you plan to grow in this career field, networking, tech, period, right? I think a lot of people, especially with AI nowadays, don't have the deep understanding. So they'll get by until it's time to go deep with the TAC case and you bring in vendors, right? And it's like, holy crap, I guess I never really knew how a packet or TCP/IP header ever worked. I just got told by engineers, do this command, you know? But yeah. So if you guys have any questions, now's the time because I'm on break from my Zoom class. So on Network Plus. Network Plus is whatever to me. I don't know. To me, that's like, if you are going to join Claude IT, it's facts. Yeah, it's facts. Claude knows all that stuff. I saw a thing that said Mythos actually broke NSA's secure networks within hours. So kind of crazy. Not a fan of our administration in America, but kind of valid that they said, hey, you need to shut that shit down a little bit. We need to get some guardrails in here. Maybe they can't even get guardrails anymore, you know? But I use Claude all the time, bro. Like for my automation that I built at my work, Claude. Yeah, bro. Yeah, Network Plus is, I don't know. Maybe you want to like, you're a programmer, you're going into cyber, you just kind of want to know like IP addressing, like the basics. Sure, Network Plus, whatever, right? But it's not shit. I had to do it because my work made me do it, and then school made me do it. And it's actually like, I'm like, damn, it's not horrible. You don't teach me IP addresses, but like CCNA does too. And then you actually get hard skills, and CCNA is harder, so I get it. Yeah, it's like, so it's basics, right? It's like if I want to show my kid, hey, here's how a computer, Claude for your automation. So 2 things. My personal project, I actually got the Claude agent installed on my MacBook, and I said, my YouTube chat's very drating me. eGrip is a cool way to say ERGRP. No, it's not. I know who you are. I'll see you at work tomorrow. Downloaded the agent, and then my goal was to use something called Ansible Tower to generate baseline configurations so my government customers can look at it from a web GUI. I can show you actually. Here, y'all want to see? Hold on. Johnny Bandon, AWX.com. So I didn't get the key. Yeah, Ansible Tower. Yeah, so AWX says I don't want to pay, but it's called something else now. It's like Red Hat Ansible Automation Controller. I work in GovTech, the DoD, and it's completely compliant Ansible Tower. So that's what I want to use because my work is not going to invest in like Cisco Catalyst Center or SD-WAN. So right now at work, I'm using Python to execute this, but I want to give my customers a front-end web GUI that can integrate using LDAP and SAML because we use Azure Entra ID. So that's my key cloak. It's not working right now though, but Claude's helping me. And then they're going to be able to go on the templates, build the baselines, and then my government customers can see our baselines and see that we're doing all the right cyber compliance and stuff like that. And then part of my NOC duties is to generate configs for deployable kits. So they're also going to be able to, instead of the way they do it now in an Excel spreadsheet, go to an Ansible Tower, select the kit number, hit launch on the rocket. There's a playbook, template, whatever, and it's going to build that kit for them, put it in a zip file, encrypt it, send it to their email, and then boom, no more human errors, right? As long as my code base is solid. So that's the goal. That's the goal, right? I don't run my own MSSP. I'm a senior lead network engineer, and then I run a company that does 8140 compliance training for the DoD. So I'm a CompT authorized training partner, and I do CCNA and AZ 104. And Army units pay my company to come in and do boot camps. So that's my company. I would love to do MSP work, dude, but it's a fucking grind, and you don't make a lot of money at first. Consulting is a good place to be. But let me see. Oh, you know what? I'll keep it real, guy. I fucking forgot my password to this because I was so focused on my key cloak. Hold on. Let me go find it in the back end. There we go. Okay, so Ansible Tower is the paid version of this, right? Go to templates right here. I do render router config. So I can choose my site, right? And I'm going to make it a drop down. I'll say I want to build R1's config. Launch that bad boy. And then the goal, right, is to integrate this with Azure Entra ID and Office 365. So all the user, the non-technical user, my government stakeholders, my customers will just get an email with a encrypted zip folder with all the baselines, and they can check it out. And then I have my GitLab over here. Where is it? GitLab. Did I put it on John.Bandon? Okay, hold on. I have two GitLabs. Hold on. Yeah, here we go. Oh, here we go. So it just built my new baselines for Chandler, right? 15 seconds ago. And I need to fork it to a delete shit. But yeah, Claude helped me build this, right? Fuck, bro. I don't know. I'm bad at career advice, man. Sorry. For me, I was in the Army 9 years. I went to a couple units that... Okay. How do you do it? How do you become a lead senior network engineer? Fucking just... Dude, you gotta... Here's my opinion. Don't be a dickhead, but don't be humble. Learn everything. Become the SME at your workplace. And then show the people that matter, i.e. the people that promote you, and a team player, of course, and be like, I'm the best, I need more responsibilities, and I will spearhead projects and take on stuff. Don't tire yourself out, right? And then another thing is job hop, too. Fucking job hop. Don't be loyal to that shit, right? Job hop, faux show, okay? Do not be loyal to a company. Like, you want to make more money? You got to job hop. That's just facts, right? Facts. So... yeah. Whoa, yeah, I know, it's crazy, right? It's incredible. Senior network engineer, automating, as in Claude's automating for me. But yeah, bro, that's how I think you get to the senior lead position. And for me, honestly, I joined this job I'm at now. I started in January, and then the lead promoted. She was not technical at all, bro. It was like it was like crazy, honestly. It's not technical at all. I don't know. Where do you work? GovTech? Of course, right? because I work in GovTech, and because of the unit I was at, it's well known in this circle that I'm in the GovTech sector. So yeah, it helps me open a lot of doors. However, my boss, right now, my boss, she was never in the military, and she's my boss. So, you know, just depends. All right, guys. I'm going to get started on the Zoom chat again because, you know, those are the guys that paid. They got the lab, so I gotta get them squared away, you know. Alrighty. So now we're going to go over static routing, guys. Oh, fuck, I zoomed in way too crazy. It's okay. I'll just static routing. So there's going to be a couple different ways that we can fit. Well, excuse me. Static routing is all the same. It is you administratively configuring that router to route to a remote network or subnet. That's all a static route is. There's multiple different types of static routes. There's a static route. There's a default gateway, gateway of last resort, which is the static route syntax. There's a floating static route, and then there's something called a host route. I'm going to go over all four, and I'm going to go over the syntax. In my slides, I had this little chart that's like static versus dynamic. We don't need to do all that. I just need to teach you exactly what I just said for the exam, okay? So let's do it. Let's do it. So we have four types of static routes. Let me write that down. So we have a static route. That's just the basic one where you're going to a distant network. We have a static route. We have a default route or gateway of last resort. This is typically done in what we call stub networks, okay? We'll go over that in a second. We have a floating static route, which is a cool way Cisco likes to call a backup route, okay? And then we have a host route. You need to know all four. You need to know all four for the exam. And I'm going to teach you with the network diagrams and the syntax. Before we get started, here is the actual syntax for a static route, guys. So when you're in your router or your multi-layer switch, from global configuration mode, here is the syntax. IP route, this is starting it. Starting the static route saying, hey, router, R1, bro, dude, we got to do a static route right now, okay? We're going to route to this distant network. Now hear these words very clearly. This remote / distant network. I need to go there. So just as a quick diagram to go along with our syntax, here's R1 connected to R2 on gig 00. And this would say is 1.1.1.0/31. Here's .0. Here's .1. And R1 needs to talk to this network over here. 10.1.0.0/24. R1 needs to talk to that network, okay? Let's get back into it. So that's going to be IP route, our distant network. Where does R1 need to talk, guys? It needs to talk over here. It needs to talk to this LAN. So I'm going to say the network address. The network address of that LAN. I need to talk to that network, the entire network. I want to talk to all the users. This is the basic static route, okay? And then you got to give it the subnet mask. Give it the subnet mask in the dotted decimal format, as we like to call it, okay? Boom, we're halfway there. So IP route to the remote network with subnet mask. So there we go, we got it. But now we have to tell it, hey, R1, hey guy, if you want to reach this over here, if you want to reach that remote network, here is the path you take. Here's where you go. You have two options. You actually have three ways of doing this, guys, okay? You can tell it the next hop IP. So from R1's perspective, what is the next hop IP? .1. We can tell it go to 1.1.1. That works. Guys, that is valid, super valid. Now, can you see a scenario where maybe that wouldn't work out as well as we want? Next hop IP address changes, you get a new subnet, whatever, okay? You have another option. You can tell it the exit interface. you can tell it your exit interface, okay? You can say, hey, you can also go out the exit interface. That is valid too, super valid. That will work. Or, check it out, guys. There's another way to do it. You can have both. Now, I can't remember what comes first. We'll do a question mark on this. You can do gig 00, and you can do the next hop IP. Crazy, right? This is always kind of like the recommended, right? Full recursion, full path, right? Either way, all three of this will get you to where you need to go. Alrighty. Now let me bring it back for a second. If I do this, so on R1, I configure that. And this is R2, okay? And let's say, like honestly, you know, we're doing this for our users. So let's say our users on R1 is this subnet, okay? If I just configure one path on R1 to get over here, are they gonna be able to talk back to me? Well, probably not, right? Because remember the life of a packet. When these guys over here need to talk to these guys, they build a packet. In that layer 3 header is what, guys? A source IP and destination IP. So there's us, and then there's them. That's going to be sent to our router. Our router is going to look at the destination IP, reference the routing table. The routing table is going to say, yo, I got you. Like, I got a path for you, bro. You're going out gig 00. Dope. R2 receives that packet. When R2 receives that packet, it's going to be like, oh, this homeboy is trying to talk to 10.1.0.10. Yeah, I got that. That's local. That's my dog over here, right? That's this user over here. You know, that's .10. Boom. So R10 receives your Teams message. You're sending a meme to, you know, .10. It's like, yo, I need to message this fool back. Oh, let me talk back. So then what does this computer do? It also builds a layer 3 header. Now, don't pretend. Let's not make any assumptions. This is all I've configured. I've just configured R1. So source IP for this PC is now going to be 10.1.0.10. Destination IP is going to be 10.2.1. Let's just say 60. We're going to send that to R2 because we're replying. R2 is going to inspect this and say, dope. You want to talk to 10.2.1.60. Let me reference my routing table and I don't have a path. So I discard you, okay? So if I build a route on R1 over here, what do I need to do as well? On R2, I also need to build a static route to this LAN. And you may be saying, because I get a lot of beginners in my classes sometimes and totally understand, well, what about this network? Guys, it's shared, okay? That network is shared between them. So you don't need a static route to the 1111 because it's local on both. So on the routing tables, R1 and R2 both know about each other via this interface, gig 00 here, okay? Alrighty. So that's a basic static route. And in this network design, that's gonna be how you do a static route, okay? You need a route to the remote LANs, essentially. The remote local area networks on your distant neighbors. That's a basic static route. Now, let's talk about a default route. So I'm gonna draw a stub network. What's a stub network, you may ask? That is when we have, like let's say a customer edge device connected to a provider edge that's on your ISP, okay? This is your fiber connection, and then downstream, you just have your users. This is called a stub. Now, why? Because downstream, you don't, or east to west, wherever, even upstream, you don't have any internal routing neighbors. So pretty much, if this is my company here, we'll call this Dope Networks LLC. Okay, maybe that's my future MSP name, right? This is my office, and I just have this. I'm a stub, right? I got no routing neighbors. I got nothing to advertise to. I literally just got to go to my ISP. I literally just send all traffic this way, and my ISP takes me to my cloud and my email and my whatever, okay? That's a stub network. So when you have a stub network, all you need is a default route. And that default route is going to be a catch-all for all your IP-based traffic. So here's how we configure a default route. We're going to go back into global configuration mode. Okay, it's going to be IP route, all 0 zeros. Okay, and then you still have to tell it two things: exit interface or next hop IP. Now, in an ISP environment, if you're not getting a static public IP, so that /31 that may be assigned to you here changes, like this may change, my recommendation is what? Just choose the exit interface, because the exit interface won't change for you, right? But it will work with the next hop IP. It definitely will work. But here, we're just going to do exit interface. Okay, that works for us. That works for us. Okay, that's a default route. Let me label this. Default route. So you may say, hey, Johnny, do we only configure default routes when we're in a stub? Not necessarily. Not necessarily. Sometimes you can have a quick little network diagram like this. Okay? We have a bunch of routing neighbors. And then we have our ISP right here. We still may have a default route here, but then we still have OSPF between here. And then these routers may also have default routes going to this customer edge here. And then this may be all internal to like our enterprise. So a default route isn't like you can only do it once and that's it. You can have OSPF, ERGRP running on your router both at the same time and still have a default route out to the ISP, okay? So it's not like a stub network is the only type of architecture you do it for, but most of the time you have one always, okay? But just wanted to show you where it's most applicable, all right? Next, a floating static route. Let's talk about that. Floating static route. Okay, so a floating static route is a backup route. So let's say we got something like this. Very simple. Okay, I'm not saying real world, this is how you're going to see it. Let's say we got something like this, all right? This is running OSPF, and this is on gig 00. I got R2 over here. I got R1. Okay? I got R3 over here. Maybe they're in like an active passive state. Who knows? Maybe they're multi-ether channel chassis, whatever. These are 8550, whatever the case may be. And they are both advertising this to you. Okay? And then this one is T1. So what are those T1 speeds again, guys? Those dedicated circuit speeds. Very old school, but very much still may come up on the exam. 1.44 megabits per second. Now off rip, it don't take a genius to know which way we want to go, right? We want to go out OSPF. Awesome. Okay. OSPF, what's the administrative distance? 110. Okay. Here is what we're going to do. We want a backup route administratively set. So we don't want OSPF between the two, okay? Because technically that would work. Let's just say, for example, we want a hard set thing. Something we administratively tell the router no matter what, you're going to go this way if this fails, right? Here's how we do that. This is a a floating static route, but it's called a backup. It's going to be IP route 10.1.0.0, the subnet mask, okay? Our exit interface will be 000. That's like our T1 speeds. Now, if I hit enter here, what's going to happen? What's going to happen here, guys? I hit enter, and it's going to prefer that because OSPF has an administrative distance of 110. The prefix length is the same. It's going to prefer the static route. So what do you think I need to do here to say, no, look, static route. You're just a backup. If my OSPF goes down, I want you to take over. What are we going to do here? We're going to set it higher than OSPF. Dude, that could be 111. That could be 254. I like doing 254 just because it's literally the last number you can pick. Okay? But this is the administrative distance here. I'm going to make this a different color so you kind of understand, that's the syntax we're looking for here. Okay? That's a floating static route. Okay. Last one we're going to talk about, running out of whiteboard space. The last one we're going to talk about, guys, is a host. Whoa. Need that in black. Okay. The last thing we're going to talk about is a host route. I swear you need to know this, okay? You may see this. It may come up, okay? A host route. This is a specific /32 static route. Let's go over this, okay? /32. You're like, what are you talking about, bro? Okay. Let's design something here. I'm going to take my time on this one. We got R1. We got these users over here on R1. 172.116.0.0/27. R1 has two connections. This is gig 0/0. This is gig 0/1. Up here is 10.10.10.10.0/30. That looks like a 6. And down here is 10.10.00.4/30. Right here is .1, here is .2, here is .5, here is .6. R2, it has these networks, 192.168.10.0/24. And connected here, right? We got our switch. We got a web server. Yeah, we'll just say web server. We got a web server. And that web server's IP address is .10. Okay, now check this out. We want this to be our primary. We want this to just be our backup or secondary, however they may label it on the exam, okay? We'll say secondary. And the question is, here's the question. Here's what we're going to ask ourselves. We want, sorry, my arms are literally fried, like I was saying earlier, from that fucking burn boot camp, bro. I thought it was going to be girly and just like easy for me. Fucking arms are killing me. Okay, we want all traffic to go out the primary interface. However, we want all traffic destined to the web server, going out the secondary connection. Okay, so the question is, or what we have to do is, all of our traffic needs to go through the primary, but when we want to talk to the web server, we want to go out the secondary. So what it's asking us is that you need a host route. You need a host route, okay? So here is what we're going to do, guys. And this is from R1, okay? I should have put that in the question, R1, okay? So R1, IP route, to our distant LAN, 168.10.0/24, going out gig 00, okay? Or the next hop IP, which is 10.0.0.2. Boom. When I want to talk to the 192 network, R1's going to send me out gig 00. Now, what's that other parameter here? What's that other thing we have to do here? Is we got to say, well, okay, but when I want to talk to the web server, when users on this LAN need to talk to the web server, I want them only using the secondary path. So we build what's called a host route. We're going to say, hey, when a user needs to specifically talk to 10.10, so /32, because we're identifying a single host. So that's why we need the /32. We're identifying a single host, so that's why we need the /32. We're going to go out gig 01, and our next hop IP is 10.0.0.6. That's a host route, guys. That is a host route. Specifically saying when users need to talk to a single host, go out this path. That's it. Those are the 4 types of static routes. All right. Whew. There's also ways to summarize the static routes. We can also add SLA and track objects to it. Then the reason you build a static host route, well, in my experience, when someone would get injured or die, like in Afghanistan, I don't know if Tyler, you remember like River City, but our general would still have to like talk. So we would cut off everyone. but then put a host route just for him, as long as with some ACLs and shit. You know, there's just multiple different reasons why you would do this. But really, for our purpose, we're doing this for the CCNA exam, right? Okay. I think we're good. I think we're going to go do our lab now, guys. Let's do our lab. So just to recap, 1 sec. Not that. Where are we at? Okay. Here's our lab. You guys go do static routing lab 1. And remember, GitLab is where our instructions are, okay? So it's going to be section 5 labs, static routing, then basic static routing lab, okay? There's our instructions. I literally went through the entire syntax with you. What I'll do when you guys finish is I'll do the show IP route commands with you, and I'll do some pings with you. And then, you know, we'll be good. So it's 7:22. Let's reconvene at 7:40. Whether you finish or don't finish, let's reconvene at 7:40, okay? Check my YouTube chat, bro. Yeah, it works. Thanks, brother. I don't know what I was talking about. Sorry. I need to keep my YouTube chat up, too. Yeah, for a host route, you need to use the /32. That you need to. When you're identifying a single host to route to, /32. Whew. I'm sore, chat. You see this? Coming out of my workout clothes? My wife killed me. If she was in the chat, I would tell her. Justin sent me here. Tell Justin, thank you, bro. We really appreciate it. Big ups, you know, thumbs up in the chat, dubs. I appreciate it. Hopefully, we can all learn something, too. Now, so no, a /32 is not a broadcast, right? /32 is not a broadcast. It identifies a single host. And as you get more into your career, you're going to see where /32s come up a lot more, okay? So like prefix list, you want to identify a single host to deny. You want to identify a single host in an ACL to identify traffic. NAT and PAT, you want to identify a single host. So you're doing like single port address translation. So many different reasons to use the /32 to identify a single IP address. Now you may say, well, on a computer, why don't you have that? Because network infrastructure versus endpoint is different, right? My endpoint needs to talk everywhere. So my endpoint needs an IP address, needs a subnet mask to know what network it is in, and then a default gateway. So of course, right? It doesn't need that. It already knows it's this IP. So you're right, yeah. Yes, so 255.255.255 is the broadcast for like the /0. And then all Fs, right? So it's like a single IP address. So you're right there. So you weren't wrong. It's just /32 can be used anywhere, right? For multiple different reasons. Okay. Before we head off, yeah. This is that baseline shit I was showing you guys. So what I need to do now, right, is, come on, see all that output. So this is the Ansible playbook, right, that we built. When I say we, me and Claude, you know, we're like two wizards in the dungeon at night, you know? Like, me and Claude just like are in there. Like, imagine like we got a little cauldron and we're just cooking, me and Claude. And I have to guide it sometimes, you know? If there's any developers in the chat, like, you may be fried, you know, because Claude be coding. But you still have to put it on track sometimes, right? You still have to put it on track. But if you guys want to see how I built this out, right? So we have our YAML files. And I did this to try to make it easy for my team. Because my team really doesn't know automation. So this isn't the most complicated automation you'll see. It's just Ansible playbook, GitLab repo. We're going to build NatoBot to do IPAM, to do IP address management. We'll build APIs to call on NatoBot to fill in our IP address variables. And then once I get that all approved by my bosses at work, we can actually automate and get into the future, you know, because they won't pay for Catalyst Center and SD-WAN, little cheap fucks, you know. Not really, but you know, and then this is like my JIT templating. So this is my JIT templating for all the different technologies in my router. And obviously it's not a full router config because it's like, you know, I'm just doing the functionality of the actual code. And then here's the playbook, the render config playbook. So it goes through everything, right? It's doing a lot of pre-tasks here that are pretty much just verifying that we're looking at the right templates and the right sites in our folder structure here. See all these errors that it wants to tell us, right? And then it's building our vars for us, right? So it's doing a lot. And then here is really like the important one where it actually builds it to GitLab. And this is all Ansible, Did you already talk about the loopback yet? Nah, I haven't talked about loopbacks yet. We're about to go over OSPF and loopbacks, we'll configure loopbacks there, you know, just to simulate like lands for our OSPF. Yeah, bro, I take breaks too, man. I study a lot. I still go over things, and I take breaks, you know. You gotta take breaks. I live a little brain break. Okay. Let's go ahead and do this, you know. Let's do some configuration while we're chilling here. Configure this. Configure this. Where's my secure CRT at? Over here. Okay. Still up from the last session. Get rid of all these network devices, you know. And we'll just side by side these damn things. And then let's get cooking, okay? Let's start doing some static routing. Oh, we're fresh. We're fresh here with our router. Hold on, guys. I'm gonna... Yeah, it's good, bro. Keep subnetting practice. You know, Cisco has a good website, too. What the fuck is it called? Cisco subnetting game. All my Gen Z coworkers show me this. They learned it in their initial training. Yeah, let's play, bro. Come on. Yo, yeah, let's play. Okay, little subnetting game. So it's saying, what's the subnet for 128? Boom. What's this? So 1, 2, 4, 8, 16. You know? How do we get to 32? That's 1, 2, 4, 8, 16, 32. So yeah, you should play this. It's good. Oh, what the fuck? The chart's down there. I didn't even see that. That's like cheat code, though. What the fuck? Yeah, you can get quick at this shit. 64. What is it? There's not even a challenge. What is this thing saying? I swear there's like a levels to it or something. Anyways. Fuck it. Yeah. Learningcontent.cisco.com. It's a great game. I wish I would have built this game myself, or I would have put ads right here. No, I'm kidding. But yeah, let's configure some static routes, guys. Lads. That's right. It eventually goes away. You're right. But it's like, damn, bro. Like, there should be like a skill level to it. Like, hey, you know, let's skill level. What game was that? It's the binary game. Okay, the binary game. How do we get 5? So that's 4 and 1. So boom, 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 boom. Yeah, it's pretty fun. Pretty fun. You know, if you're starting out. Okay, let's do some configuration. Configure some static routes. If you guys in the chat want to see something else during the breaks, let me know. You know, I can bring up a Linux terminal. We can go through some Linux type shit, whatever. I do networking every day. I would even show you guys some cloud stuff, but I don't want you guys like getting into my cloud environments, you know, with the public IPs and stuff. One day I'll teach AZ104 live too. We can learn some cloud and networking shit and IAM and role-based access control. Let me text my wife real quick, guys. Hold on. Do I want Carrabba's? Hell yes. Okay. Let's do some static routes now. So, do show IP interface brief. What the fuck's going on? My messages are like being loud, dude. Why? It's never done this noise before. Okay. My wife got Chipotle. Let's go. Bro, I muted him, bro. I muted him, bro. I don't know what the fuck was going on. I just never made a sound before and I'm texting on my phone. Thanks, Josh. Thanks, Josh Tech. If you guys didn't know in the chat, I'm in a clout chase right now. Me and Josh Tech work together. We're in, well, I think we're in the Army. No, I was out of the Army, but I taught his unit. And then he came and worked where I was at as one of our tier 2s. He's, well, honestly, one of our best tier 2s. And then he dipped on us for bigger and better things, which is what you should be doing, right? Job hopping. Okay, so show IP interface brief. We'll do it over here. Do show IP interface brief. Okay, so R2's got its LANs configured. Well, let's go and configure the LANs over here on R1. So we're going to go interface gig 01. We're going to no shut that interface. That's the physical interface for our sub interfaces that we're about to create right now. Wait, hold on. Let me go into linecon 0, logging synchronous, because I don't want those fucking syslog messages interrupting me again. How dare they? Okay, back into our sub interface. Now we're going to be doing this for VLAN 10, I believe. And then we're going to give it an IP address. 192.168.10.1 slash, is this slash 24? Let me check my, yeah, royal slash 24 is my network diagram. So we're on break right now from the Zoom, but we're doing static routes and OSPF. So you missed the fucking whiteboard sesh, bro, but yeah, we're doing OSPF now. Sometime, bro, we should collab on the live and go over wireless and like some CCNP shit. Okay, we can whiteboard that shit out. Give back to, you know, the fellas, the community. All right, back on gig 01, we're gonna go sub interface 20, encapsulation .1q 20, and then give it that IP address. 20.1, 5.0. Okay, we're good to go now on our LAN. So this is R2's interface. Let's go ahead and check out gig 00 here. Should be a /31, it is, which we can do on a point-to-point, right? So what we're gonna do is go to interface gig 00, IP address, and this is gonna mess some people up, but this is the actual IP address. Now usually you try to configure a .0 with any other subnet mask. It's gonna be like, nah, that's the network ID, playa. Yeah, I can do SVI. It's just my environment is this, okay? You know, so that's why I'm doing the router. But yeah, you could do an SVIs here, but then it's my router that needs to route for these LANs because I like to teach the students to do static routes on the routers, right? So, okay. But yeah, totally, you know, totally possible. Yeah, you're right. It doesn't have a lot of resources. It has a few books, and that's about it. Like even INE, if you go to ine.com, Josh, I don't even think it has that any either, which is like, for you guys in the chat, INE, once you get past CCNA, CCNP level, this is the gold standard for training. This is what I use to train myself, right? But it's expensive as fuck. So try to get your company to pay for it. But it's fucking solid. CCIEs, train it, right? Let's check wireless here. Yeah, you know. Let's see. CCNP wireless. Josh, if you're still in the chat, are you still learning? Are you still doing Cisco wireless LAN controllers? Like on-prem, or are you doing Meraki where you're at? Or a little bit of both? Yeah, there's not a lot of wireless like for the CCNP. Okay, back to configuring. So what's ping? Can we ping? Whoa. Oh, you know what? You know why we didn't ping, guys? Can anyone tell me why in the chat? We're down. I forgot the no-shut, dude. Rookie ass move when you're going too quick and talking, right? Got a no-shut? Let's do that ping again. Nice. You got a physical 9800? You virtualizing that thing? Oh, okay. It's in an AP. Okay. Yeah. Makes sense. So you bought the AP and it has that running? It's true, bro. It's a network ID, dude. You know? It's like, hey, big dog. Like, that's a network ID. But the /31, it's fine, right? No network ID, no broadcast. Nice. That's good. That's actually a good deal. You should virtualize it, though, bro. You should virtualize it. Get a little shitty-ass computer from, like, off Amazon. Put a little hypervisor on it. Virtualize it. You know what I'm saying? Does anyone have any book recommendations about networking or cybersecurity? Bro, come on. YouTube chat. Does anyone have any book recommendations about networking or cybersecurity? It's a loaded question. TCP, IP, networking. Cisco Press. Guys, for anyone in the TikTok chat too, if you want the no bullshit, you want to be smarter than fucking Chat GPT and Claude when it comes to networking, this is what you got to get. It's old as fuck. It's old, a little old, but this is it. This is it, guys. You need this book right here. This teaches you, like, CCIEs till this day say read TCP IP Volume 1, Volume 2, if you want to learn the no shit, everything about that protocol. Pretty much when I built my OSPF section for this course, I read OSPF here, which is damn near like reading the RFC actually. And ever since that day, I read through OSPF, made my slides based off that. Bro, I know OSPF. Like, I know it. Obviously, I don't know everything, right? You forget shit. It's whatever. It's perishable. But it was the best. I'm like, dude, this like breaks it down the best I've ever had it. And still to this day, CCIEs will recommend these books. I'm telling you. Ethical hacking, that's what's up. That's what's up. Cyber's fun. Cyber's fun when it's actual blue teaming and red teaming activities, right? It definitely is fun. Where I'm at, dude, in Gov Tech, when it's like blue team cyber and you're just like an ISSC, ISSO doing information assurance, it's fucking disgusting, bro. It's just paperwork. Yeah, Network Warrior by Gary Donahue is fucking amazing. I read that when I first started as well. And that's like real world. It's like CCNA, cool. Here's real world how networks are designed and the issues you come in with them, right? Bro, it's facts. You know what I'm talking about, dude. Paperwork, GRC, no hate. There's like literally no hate on any tech. Anything in tech is good, right? It's just a personal opinion. Like GRC is so boring to me. I'm like, bro, I get it. PCI DSS, NIST risk management framework, cybersecurity framework. Are we hardening correctly based on these benchmarks? I know. You'll never be smarter than ChatGPT. I know, bro. It's jokes, right? But dude, Claude, I don't know. But I'll tell you this though, in our network shop, we've been going through lifecycle replacements. We're putting Palos. We're doing a whole architecture redesign. Dude, ChatGPT doesn't always get it right, man. It really doesn't. Like with the Palos especially, Cisco, it's pretty good. But when it's a GUI, when you have to go GUI based, these AIs do not do a solid job of it. Linux configuration, Cisco CLI, hell yeah, right? For sure. But I don't know. You know what I mean? Like when it's GUI based, not too good. I had Claude try to help me with my Keycloak single sign-on my AWX tower site, and it's been having issues. And I almost, like, I'm literally about to say, fuck it. I'm going to read how someone did this on their Reddit page and try to GUI it myself, you know? Yeah, it just depends, right? It literally just depends. From what I've seen, Linux, my network automation projects, programmability, object-oriented programming, uploading your Git repo, taking a look, solid, right? Boom. Yeah, of course, AI. I mean, AI is a tool, great tool for anyone. I use it in my day job. You know where it's helped me out? It's made me a generating force, right, with AI, is when I'm building documentation, right? I can just spam my white paper, spam all the info, the architecture change, whatever, spam it on a Word doc or in Markdown. Everything I know, everything I do, everything I want to explain, I prompt AI with a deep prompt. I upload that and say, make this a nice format so I can give to my government stakeholders. And it creates an amazing Word doc, formatted cleanly, no errors. That's where it helps me, right? It's like a tool. It's like my little buddy. Like I said, it's like my wizard. We're in the dungeon. We got a cauldron and we're cooking shit up, you know? Can it be deployed on a switch and troubleshoot as effectively as me? I don't think so, not yet. Can it be deployed in a Meraki cloud, in a Catalyst center, look at things, give suggestion, and can you make it do intervention? Of course. But do you want that? Now all of a sudden we have AI, so we don't have change management? Like, it just doesn't make sense, right? Nice. I've really wanted to do that for a while just to see how to. What model are you using? Like, I don't even know. What's the open source model, right? Is it ChatGPT? You can use OpenAI. A little DeepSeek action, you know what I'm saying? A little Chinese AI in there. Oh, my other guy that paid for this course isn't here, dude. Olama? So I need to get more spun up on AI because I just use Claude, bro. Like, I just Claude, ChatGPT, prompt. Okay. let's go ahead and build the static route. I'm gonna, let me share my screen with my Zoom call. Hold on. I have 3 students in here. They couldn't make it today. I think it's a 4-day for them, so they're just kind of like, Okay, TikTok, YouTube chat. I gotta go back to my Zoom caller, okay? Just, on break we can chat. Alrighty. So it looks like it's just me and you, Marcus, so we can get into it though, bro. It's fine. Tyler, he's, somewhere where the internet's probably not good. Okay, so I'm just gonna build some static routes right here, and I wanna show you something, okay? 16.10.0, subnet mask, okay? Let's go out the exit interface, and as you can see here, you can still put the next hop IP. So just wanna show you the syntax for that, okay? And then for this next one, we can just choose exit interface, and that'll also work, okay? Alrighty, on R2, let's take a look. Show, do show run, pipe section, IP route. Okay, so we just have a default route. I'm gonna know that out. So here, man, I'm just showing you how to interact with our running config in a way that you don't have to scroll through everything. So here, I just want to see my IP route section. So this is called regular expression here. And this pipe pipes you over to your regular expression that says, hey, my running config, I just want to see this section, okay? Got rid of that. Up arrow, try that again. It's no longer there. So now we'll just IP route over to the networks over here, okay? And we'll do IP route 192.168.10. .0, 255.255.0, gig 00. We'll up arrow that bad boy again. We'll do it out 20 as well, okay? Now, let's try some pings. So I'm just gonna try to ping the other side here. I'm gonna try to ping .1 from R2. Let's see what we got cooking here. Okay, we're successful. We missed a ping, we'll call it we missed, because we had to do address resolution protocol. We had to pretty much build this, okay? We had to build our layer 3 to layer 2 mappings, so we sent a gratuitous ARP at first. If we're looking at the wire, we built the ARP table, and then we could send our full packet with that layer 2 correct destination MAC in the header. Okay, now, guys, question for you. What I just did, I pinged my users over here from my router, okay? Does that confirm that my users here can talk over here? The answer is no. Crazy, right? When I do that ping, if I were to have a Wireshark capture right now on there, the destination, my layer 3 header, here's how it would look. The destination IP is to our destination, 192.168.20.1, but what's my source IP? My source IP is actually going to be the interface closest. So all I verified was that this network can ping that network. That's all I just verified. So you may say, well, what's the best way to test it? Go to the user, see if the user can talk to the other user on the other side. So where's my network diagram? Hold on. Just go to the user and ping, try to ping this user. But if I'm at the router, and that's all I have, okay, what you can do is this command right here, guys. This command right here. So it's do ping, the other side, 20.1, and then we're gonna go source gig 01.10. So now what we did is we changed that source IP to this right here. So now in our packet, check her out, this is what it's gonna have. 172.16.10.1. And now we verified that both LANs can talk, okay? Alrighty. Marcus, I'm gonna give my voice a break, brother. Let's see where we at. Fuck's my Zoom at? Hold on. Oh, hold on. Let's clear all these drawings. Dude, I don't know where my, oh, there it is. I'm gonna give my voice a little break, dude. We're going to come back at 7:55, and we're going to do OSPF on the whiteboard, okay? Alrighty. TikTok and YouTube chat. Yeah, section. It means section, SE, section. And it's just regular expression, right? It's regex. Same way you use regex in Python, the same way you use the grep command in Linux to filter out a file, to find something in that file, like you're doing log dives, whatever. Same thing. Well, it was static routes. We can figure that already. Now we're about to do our OSPF lesson. About to do the big OSPF lesson. Okay. Let's get it. Let's get it. Mr. Make It Happen. One of my old OICs had that name as his handle on Instagram. I don't think that's you, but anyways. Okay. Let's see. Two stroke length. So now we're gonna go over OSPF, guys. And to keep it 100 with you, I'm gonna make sure I do this the most accurately I can. Now I don't know why, but anytime I bring slides into my TikTok chat or like into view here, it fucking restricts me. It says I don't have original content. So this is gonna be all whiteboard, but I'm gonna have my slides over here on the right, just in case, right? Just in case I don't wanna mess up something simple here. Okay. Here we go. OSPF network types, yeah. We're gonna do this thing, okay? Here's what I'm looking for, the formation overview. I wish I could show you guys the slides I'm looking at, but it literally restricts my TikTok. I'm talking like within 10 seconds, I fucking get restricted. But it's just my OSPF slides, okay? Okay, let's do this thing. So OSPF, open shortest path first. What I'm gonna do here, just make my routers R1 connected to R2. They're gonna be on gig 0/0. They're gonna share this network here. /30, whatever, guys. We do /30.2, okay? And then we're gonna do like a semi deep dive, right? Into OSPF as best we can, For you guys just joining, fucking, my wife took me to Burn Boot Camp today. I was talking that big shit about it. Say that's whatever, I'll kill it. It was like fucking push up, pull up, lift day all for fucking 30 minutes straight. So my arms are cooked. So if you see me looking a little tired, it's because I am. And even though I took my Adderall this morning, but obviously that shit wears off. So yeah, a little sleepy. I'm not even sleepy. I'm just like fucking exhausted, right? So I'm trying to keep the energy up as best I can. Alrighty. Okay. Because I'm gonna actually I need to organize this a little bit. Let me get it a bit right here. Move that right there. Move that right there. Zoom out just a little peep, right? Okay. Yeah, thank you for everyone following, right? Staying tuned to the lives. I appreciate it. Maybe I should do this more. Thanks, bro. Jeb Boogerman 4759. This nice AF. I appreciate that, bro. Hopefully you're learning something. Okay. So OSPF. We're first gonna go over neighbor adjacency. Neighbor adjacency. Don't fucking check my text. /forming neighborship. This is step one. Yo, chill. This is step one in OSPF. Forming neighborship, okay? All right, Marcus, fuck it. Let's just start now, bro, so we can get through OSPF and then call it a day. Okay, so now we're going to talk about OSPF, guys. This is the routing protocol that will be tested on the CCNA. This is it. This is what we have to know. It's what we have to understand. We got to understand the OSPF rules, how it forms. We got to understand its bandwidth, its metric, its cost, values. We got to understand what forms adjacency and what it does with its link state database, what LSAs are. We got to know how to configure it. We got to know how to set OSPF priority. We got to know the different network types of OSPF. And I'm going to try to accomplish that for you guys right here, okay? Let me bring up my slides on the right, again, like I talked about, so I don't miss anything. Okay, so first thing we're going to talk about is establishing neighborship or neighbor adjacency. Link state routing protocol. I'm going to say this over and over and over again. OSPF forms neighbors based off, you guessed it, the link state. So what's going on with that link between routers is how OSPF forms. You could almost say that when I configure OSPF, I'm not configuring even globally on the router. Like you'll see, yes, you go to global config mode and do it, but really you're activating OSPF on a per link basis, per link. That's really what's going on when I configure OSPF, okay? So step one, forming adjacency, neighbor adjacency, forming OSPF neighbors. As we form neighbors, guys, we're gonna go through 3 different states. There's 7 total states in OSPF. Technically it's 8, but we're gonna go over 7 for the CCNA. There's technically 7 states, okay? Here are the different states we're gonna go through to form neighborship, okay? So that's going to be the down state, the init state, and it's gonna be the two-way state, all right? That's step 1, form neighborship. The next step is something called synchronizing our databases, and that's when we start exchanging what's called link state advertisements to build the OSPF database to then get to a full state to then build your RIB or your routing table. Now, those are the states. Now, how do we get there, guys? How do we get there? I will tell you. So to form neighbors, OSPF starts sending something called hello packets. So when I enable OSPF on R1 and R2 here, and I say, hey, OSPF is going to be activated for this interface, configuration layer, the first thing it's going to start doing is sending what we call OSPF hello packets. Whoa, not a R. Hello packets. We're going to start sending OSPF hello packets. Boom, done. Now you may say, what's the destination for these OSPF hello packets? It's actually a multicast address called 224.0.0.5 and /6. .5 is the multicast for all routers. Excuse me, the BR DDR routers. .6 is for multicast all OSPF routers. So with any OSPF enabled device on your shared Ethernet segment, listening for that multicast space, you'll get these hello packets. And then once you receive the first hello packet, then you send it via unicast to this .2 or .1. Not testable, so I'm not going to write it out. Sorry. But just so you know, right? I want you to have all the information possible. Okay? Alrighty. So we start sending hello packets. So you say, okay, what's in those hello packets? I'm about to go over that with you. So those hello packets contain 4 pieces of information for you to establish neighborship. Remember, we're establishing neighborship. Once I activate OSPF, guys, I go into the init state. The down state is like OSPF is not configured for this interface yet. But once I configure OSPF for this interface, we go into the init state. During the init state is when we start sending the hello packets, okay? That's when we start sending the hello packets. So what's in these hello packets? Okay? To form neighborship, we need 4 things to match. And guess what? This is all in the hello packet. You guessed it. This is all in the hello packet. Let me change my font size. Okay? Maybe a little bit bigger. We need 4 things to match in the hello packet. First thing are hello/hold timers. Guys, in OSPF, there's something called hello and hold timers in that hello packet. If I were to Wireshark this out and show you the OSPF header, like the actual IP packet header, there's going to be a field in there for hello/hold timers. Now, OSPF also has 4 network types. This is going to come into play. Depending on the network type, it's going to change your default hello and hold timers. So let's go over that. These need to match. So the default hello and hold timers are 10, 10/40 seconds. And this is for the broadcast OSPF network type. And guess what? This is the default network type. So if I configure OSPF and I don't change my network type, this is what I'm going to have by default. 10 seconds for the hello, 40 seconds for the hold timer or dead interval. Sometimes it's called. Actually, no, not sometimes. It is called that as well. Hold timer, dead interval, synonymous. Okay, it's 10 and 40 seconds by default for the default broadcast OSPF network type. Okay? Alrighty. Then we have 10/40 seconds. And this is going to be for the point-to-point. I'm going to bring up my slides here and make sure I'm not messing this up, okay? I believe the 10/40 seconds is also for the point-to-point. Hold on. 1 second. Yep, I was right. I should have second-guessed myself. For a point-to-point OSPF network type. Now, this is not the default, so guess what you think you'll have to do here if you want to do point-to-point? Go and change the interface. You have to get into the interface and change it. And then it's 30/120 seconds for the point to multi-point OSPF network type. And then it's also 30 to 120 seconds for the NBMA. I'll type that out. Non-broadcast multiple access network type. Okay. All that to say they need a match on both sides. That's it. Hello and hold timers need to match on both sides of the link. Alrighty. So what's next? What else needs to match? What else needs to match, guys? Is the area ID. The area ID. This is a 32-bit address, a 32-bit identifier, technically, okay? And by default, all OSPF areas should be in the backbone area when you're first starting out, okay? So the area ID needs to match. So the backbone area is area 0, or like if you're in a Palo Alto, here's how they put it, area 0.0.0. Same, okay? They need to match. So if I put gig 00 in area 0, and I put gig 00 on R2 in area 10, am I gonna come up? No. Now, we could have a scenario like this, where, okay, this is area 0 right here. This is our backbone between R1 and R2. R1 has another neighbor, R3, and that technically could be in area 51, and then we call that router an area border router. Totally fine, totally possible, good to go, okay? But per link, it has to match. It has to match per link. Link state routing protocol. Okay, what else? What else are we cooking with here? What else needs to match is MTU, the maximum transmission unit on the interface, at the interface level, needs to match. So what do we mean by that? 1500 MTU, 1500 bytes I'll put, is the default, okay? 1500 bytes is the default. If I go and change up here, this interface to MTU 1400, and I leave this at default, we will not come up. We will not come up. The MTU is the total size of your packet, 1500 bytes, to include headers, okay? So your data sits somewhere like 13 to 1400, depending on how much headers you have, layer 2, layer 3, layer 4, layer 5. And then if you're doing like VPNs, it's even more and shit, you know, like IPsec. Yes, MTU needs to match. On the CCNA exam, NBMA does not matter, and the point-to-multipoint does not matter. Point-to-point and broadcast is what they're going to talk about in the CCNA exam, okay? All right, what's the fourth one here? A lot of times people say this is an optional one, and they're dead-ass wrong, because the fields need to match. Remember, this OSPF packet, there's going to be a header, and in that header, like if I were to draw it out, like in this OSPF header, like there's going to be like the area ID here, there's going to be like the router ID here, there's going to be the hello timer, the hold timer, the MTU. I'm going to delete this, right? And then there's going to be like a section for authentication. If you don't configure authentication between these two, as in you don't set a password that needs to match between these two links, these two routers, fine. This is blank. That means they match. But on R1, if I configure a password of like Cisco, like that's my pre-shared key, for OSPF, it's Cisco, and I do nothing over here in R2, we will not come up. We will not come up. So authentication also needs to match. People call it optional sometimes because like you don't need to configure it, right? But same with the hello and hold timer, same with MTU. So to me, it's not optional. So if you hear a trainer say that, don't give them a hard time, but not optional, okay? Authentication. I'll just say this is like on Cisco, this is your keychain / your PSK, pre-shared key. Alrighty. That's what makes us form neighbor adjacency. Now guys, very important here. When I move forward, now what I'm about to teach you, this deals with the default network type of broadcast OSPF networks, okay? During this exchange of hello packets, there's also something in that OSPF hello packet called the OSPF priority. The priority, okay? NBMA is non-broadcast multiple access, sometimes dealing with like DMVPN kind of type stuff. More on that later. OSPF priority, okay? This OSPF priority is going to matter a lot when it comes to our broadcast network. Let me take a quick breath. Let's go through this, okay? Well, let's say we have an environment like this, okay? It's a bad looking router. All these routers here. And they're all connected on a shared Ethernet segment. They're all connected, okay? I'm going to label them R1, R2, R3, R4, R5. I configure OSPF on these bad boys. Area 0, let's just say. Area 0, right? Okay, once they all become neighbors, and we're about to go over this, what happens when neighbor adjacency is formed? OSPF, the protocol, starts blasting out link state advertisements. In those link state advertisements is the network that you know about. So it starts blasting out to that multicast address that all OSPF routers and interfaces listen on. I know about all these networks. So R1 blasts out to all of its neighbors. I know about all these networks. R4 receives that and it says, dope, I just learned a new network from R1. I'm going to blast that out everywhere. R2 receives that from R1 and R4. I'm going to blast that out everywhere. You kind of see what we're getting here? There would be a crazy broadcast storm, right? Not necessarily like STP broadcast storm, but it's just chaos. It's chaos with link state advertisements. So this right here is a broadcast default network type. They're all on a shared Ethernet segment. Imagine a switch in between there or something, and they're broadcast. And so it's in the name. They're sending these updates everywhere. This is after neighbor adjacency, okay? So the creators of OSPF saw this, and they said, you know what? During step 1 here, what we're going to do as well, besides just forming a neighbor adjacency, we're going to have to set what's called a DR and BDR, a designated router and a backup designated router. And that designated router will receive all the updates from all the neighbors in an area, compile them up, build its database, and then send that single database out to all neighbors. And that's how they're going to sync their OSPF databases to know about all the remote networks in an OSPF area, okay? Why did I bring that up? Because that happens during this phase, okay? So another thing that happens during this phase, and that's not included into form neighborship, for the broadcast network type, during neighborship forming, the hello packet selects a DR/BDR, a designated router / backup designated router. The DR receives all OSPF link state advertisements. You're going to learn these. And builds a link state database to send to all neighbors. Okay, now back to the whole point of this. Johnny, you just said OSPF priority here. Okay. How do we elect a DR? I'm going to delete this over here because it's not important anymore. How do we elect a DR? Okay, I need some space to type out my notes so you guys get solid notes. So how do we elect a DR and BDR? Well, you'll see. Electing a DR/BDR. Multiple steps. Highest OSPF priority wins. The OSPF priorities are 0 through 255. Default priority is 1. We set this priority, if we want to set it, at the interface level. Guys, it's easy, right? Highest OSPF priority wins. If I set up R1's interface gig 00 to IP OSPF priority 255, I'm the DR, baby. You know, I'm going to be that designated router. Let's say we don't do that. Let's say we don't do that. The highest RID, router ID, RID, becomes the DR. Okay, the DR. The DR with the highest router ID becomes the DR if the OSPF priorities are all at default. They're all the same. Okay, we're all the same, essentially. So if you set every router to priority 100, that's the same problem, right? Highest router ID becomes the DR. But what is the router ID? What is the router ID? I actually wrote it right there in my really bad handwriting, so sorry. Router ID, okay? That is a 32-bit address that identifies that router for an OSPF area. So the router ID is a 32-bit address, IP address, that identifies a router in an OSPF area. Okay, so you can hard set it. So you can hard set, you tell it what the router ID is going to be. If you don't do that, the router will automatically select the highest loopback interface. If you don't have loopbacks configured, it'll select the highest, and here's the important part, active interface IP address. Okay? Okay, so if you don't set a router up with the higher priority, they're all at default, they're all the same in our OSPF broadcast area, broadcast network type. It's going to select the router with the highest router ID. Okay? How a router selects the router ID. You either set it yourself as a network engineer, or if you don't, it'll select the highest loopback IP, or if you don't have that, it'll select the highest active interface IP address. Active interface, so no shut, up interface. Okay. Damn, we're cooking. So that's everything I want to talk about when it comes to this phase of OSPF, the forming neighborship phase. So important things is what needs to match. That's over here. The network types, you got to know the network types, okay? And then the broadcast network, how it elects a DR and BDR, okay? Now, one thing I'm going to put here, an extra note. Point-to-point network types do not need or have a DR/BDR. They don't, okay? So you don't need to worry about that. So on the exam, you see something that doesn't have a DR/BDR, like in your show IP OSPF neighbor command, there you go. It's not broadcast, right? It's not the default. Now that's phase one, guys. I'm going to take a moment to let you take some notes. I'm going to move down here because guess what we got coming up? Phase two. Now that we formed neighbor adjacency, what is our next phase? What is our next phase? So R1 is connected to R2 here. R2 has all these networks. /24. No, I don't like that. Hold on. I want this in an Ethernet segment so it's very accurate for you guys. Okay? R3 has all these networks. Okay? And then we'll have our own networks here, but whatever, it doesn't really matter for this. Okay? So, I don't need to put IPs, whatever. Just know they formed neighbor adjacency, and R1 became the DR. Okay. So, the next thing we got to do is synchronize. Synchronize our OSPF link state databases. Alrighty. So with OSPF, guys, you have three tables essentially. You have your adjacency table, which is all your neighbor information, and then you have your link state database table. That link state database table is all the information OSPF gathers from all of its neighbors. It does its metric on them, selects the best path, and then inserts it into your routing table. That's the three tables of OSPF. Neighbor / adjacency table, link state database table, and then of course the routing table that takes the best routes from that link state database. So now why am I saying this? Why does this matter right now? What am I going over? Okay, I'll zoom out just a tad. Okay. I don't like the way I did this. I need to give myself more space. Hold on. Okay. So, okay, sorry. So this is going to be the X start phase. Remember I said there's phases. The exchange phase, and then the loading phase here, okay? R1 is going to be the DR. So now we're going to have what's called, and this is the language that's in the RFC for OSPF, a master-slave relationship. That's what it's called, okay? That's not from the networking guru or me, Johnny Bandon. That is the OSPF RFC. You can look it up, okay? That's pretty much establishing I'm the DR. So now, during the XStart exchange phases, we're going to send what's called link state advertisements, okay? There is 4 types of link state advertisements, okay? There's the update, there's the request, there's the acknowledge, and then there's also something called a database description packet, okay? Well, let's go over how this works, guys. So during neighborship, we established that R1 is going to be the DR, the designated router. So what's going to happen is R1 here, I'm going to put this in like a timeline, and this is to all the routers. It's going to send what's called an LSR. It's going to send a link state request. Now what happens here is that R1 over here has a link state database list, okay? Link state database list. Essentially that list, I'll draw this out over here, is empty. It's empty and it needs to be filled up. Okay? This will eventually become that router's link state database. So I send my LSR. And I also send what's called a DBD before this. A database description packet. Okay, I'm going to delete this LSR. Sorry. Okay. So we have our link state database list. Okay, link state request list, whatever. It's empty. And I need to know about what all my neighbors know. I need to know about all their networks, okay? So the first thing I'm going to do is send my database description. I'm going to say, hey, neighbors, here's what I got over here, okay? And here's what I need from you. The neighbors send back their DBD. That DBD is essentially going to say, like, hey, R1DR, I have 3 networks, and I'm R3, I have 4 networks. So then with that database description packet, R1's going to say, cool, I'm expecting R2 to have 3 nets. And I'm expecting R3 to have 4 nets. All right. So now I need to send you guys 7 LSA requests. What do you think they're going to do? They're going to send back LSA updates. Essentially what happened here is we got their database description packet. They told us, each neighbor, like, hey, I got these many networks to share with you. I inserted those as a DR into my empty link state request list or database. I said, okay, cool. I need to send an LSA request for every single network that they told me they have. So they send all the LSA updates. I send back an LSA acknowledgement for every single update I get. And then I fill that information in, and everything that goes along with that. If R2 is telling me about a network, here's its subnet mask, here's its cost, here's its bandwidth, right? All the information. And once this is full, then what do I do, guys? I then, as a DR, I send my entire link state database that I just filled up from my link state request list. I send that to every single router, neighbor, and they synchronize with me. Because as the DR, I got all the information about every single neighbor in the topology. I build my link state database, I send it to my neighbors, and then we all have the exact same link state database. We all know about all the remote networks and routes in our OSPF area and topology. Because they could be intra-area, inter-area as well. Once we do this, once we're there, and they receive that link state database, those are supposed to be check marks for R2 and R3. We're in that loading state. So what comes next, you may ask? Now, we get to our full state. So what comes next? We just synchronize over our link state databases. But the end goal is that we have a routing table that's accurate, that knows the best path to things, okay? So with that being said, right, what do I now need to do with my link state database? I have to execute the shortest path first algorithm. I execute the shortest path first algorithm against my link state database at every single router. We're all synchronized, we all have the same one, so we're gonna get all the same outcomes as far as like the best cost, and I do that. So what is the SPF algorithm? It is something called a reference bandwidth divided by actual bandwidth. Okay, so let me get some more space and let's go over that, okay? And the issues we may have with that. So I got R1. It's connected, it's connected to R2 here. Also got a connection to R3, and I got a connection to R4. This is 10 gig, this is gig, this is fast Ethernet. Okay, how many megabits is in 10 gigs? So, equals 10,000 megabits per second. It matters. 1 gigabit per second equals 1,000 megabits per second. Fast Ethernet equals 100 megabits per second. Now, I just told you about the OSPF algorithm. It's a reference bandwidth divided by an actual bandwidth. So how do I determine the best cost, right? Because let's say I got these networks. Okay? The same exact networks being advertised to me. I'm R1. I need OSPF to tell me to go out the 10 gig way, right? That's my best bandwidth there, right? Best bandwidth is how OSPF works, okay? So the reference bandwidth in the OSPF algorithm by default that the CCNA wants you to know about, divided by the actual bandwidth of that link, my handwriting's getting sloppy and getting tired, is this. It's crazy. 100 megabits per second divided by actual. So guys, let's take a look at that. So if I'm R1 going to R2 in my diagram, I need to calculate the cost based off my default algorithm. 100 megabits per second divided by 10,000. If I'm R1 going to R3, that's 100 megabits per second divided by 1,000. R1 to R4, that's 100 megabits divided by 100. Now here's a little hint I'm going to give you. There's no decimals in this game. There's no decimals in this OSPF game. So what ends up happening is by default, OSPF says that my metric, my cost for all these links is 1. That's a fucking problem, right? So what do we do to fix this? What do we do to fix this? What we do essentially is we have to tell OSPF, hey, that reference bandwidth is out of scope, bro. We need something way higher. We're dealing with 40 gig links now sometimes on the WAN. Crazy, right? Well, yeah, we are. What we got to tell OSPF here is change your reference bandwidth to this. Change it to this. And then you get a more accurate report. And then when we change it to that, now it's 10,000 megabits. Here's what actually happens. This is 1, this is 10, and this is 100. And now this router knows that that's the best path. That is the down and dirty of OSPF. So it is 8:20 here on the East Coast. My kids are fucking screaming, and they're ready for bed. And my wife's in there. I was at work today. We worked out, and then I came back here and immediately started teaching. And I got to call it quits, okay? My voice is killing me too. So for the guys in my Zoom chat, Marcus, if you're still there, just do the OSPF lab. We'll go over it again when we meet on Wednesday. So I'll show you. Stop all nodes, right? Close the lab. Section 5, OSPF. Basic OSPF lab, okay? Go ahead and do this. I'll do the advanced one when we come back on Wednesday, and then we'll keep pushing on, man. If you're still there, it's okay. I do the same thing on my live trainings. Oh yeah, okay. I appreciate you coming and staying along for the ride. Thanks, brother. All right, my TikTok chat, YouTube chat, I'm fried. I'm gonna go inside. I'm gonna help my wife. So I appreciate you guys coming, and I'll see you in the next one on Wednesday if you want to come. Thanks, dude. I'll email you back.